set up our own tunnel broker, basically. So no matter what network provider we had in a hotel, usually we get a sponsor to come in and give us a DS3 or whatever for our meeting networks. But we could provide our own V6. So we'd set up a router on the edge and we'd tunnel back to the ARIN offices and we'd get V6 to our members so that we could say, all of our networks are V6 enabled, try it out, let us know if you can get it to work. This led to us doing tutorials where we would spend like half a day with people at our meetings, helping them configure IPv6 on their laptops to get it tested, whether it's Windows XP or Vista or Linux or Mac or whatever. We'd set up DHCP-v6 servers, or we'd use RA, or we'd use Slack, whatever. Try out these various things, try to get them to work, and it was a really cool exercise for both ARIN staff and for the members that attended our meeting. This evolved over the years into a test bed for all sorts of transition technologies. We've tested NatPT, Ivy, which is kind of a variation on NatPT. It's developed by the Chinese, and I think that it's basically dead as well. It's worth noting that NatPT is also dead in the water. Nobody's really using it anymore. Things like NAT66 and NAT64 are in the work at the IETF. This kind of goes back to the IETF finally starting to take the transition seriously, which is something that's fairly new. We've also tasted a lot of the CGN technologies and NatLight. John mentioned earlier Comcast and the work that they're doing deploying V6 in several different modes. And one of the things that they're doing is something called NatLight, which basically deploys RFC 1918 V4 space to a customer on their internal network and then uses V6 transport from their CPE up to the network to another big NAT box that strips off the V6 and converts it back to V4 to get people to the V4 internet. We've tested that at our meetings. You can actually test that yourself, it's worth noting. It was developed by ISC. It's completely open source. You can go to the website and download it. There is an image for OpenWRT, or you can deploy it on any Linux box. And it works actually really, really well, surprisingly so, at least on a small scale. We'll see how it works in large scale rollouts. Comcast is finding out right now, I believe. So how much V6 traffic do we see? We don't see a whole lot. I don't know if you can see the red on these graphs, but there is some red on there, I promise. We get a lot of traffic. We're a little tiny company. I think ARIN's about 50-something employees, but we get a lot of traffic. We get many hundreds of megabits worth of DNS traffic, for instance. So in a way, 0.5% of DNS traffic over V6 is actually really good. Who is? I think that this stat is a little bit wrong. It's gone up a little bit. So I think by the end of the year, we'll start to see probably about 0.5% of who is traffic over IPv6. Web traffic is kind of interesting. We get over 0.5% of web traffic in general, which is kind of high for most sites. If you look at other sites out there, they're a little bit less. If you count ARIN into these statistics, we get almost 10% of our traffic over V6. Because internally, so many of our hosts are dual stack that all of our push scripts and everything else goes over IPv6. All of our monitoring for web content and stuff, that happens over V6 now. So we generate actually quite a lot of V6 traffic internally. I think that kind of helps speak to how well it generally works. It does just work. So that's kind of the end of the ARIN networks. I want to talk a little bit about security. This is DEFCON, and I think that this is something that everybody likes to think about here. We learned a lot about security, and I think that it's worth noting how security changes in V6. What's different? Many things are the same. John hinted at this in his presentation as well. TCP is still TCP. UDP is still UDP. You still have source. You still have destination. You have things like QoS and all these other mechanisms. That's really all the same. If you understand that in V4, you understand it in V6. But there's a lot of differences as well. There are a lot of unknowns. V6 stacks really aren't all that well tested. Nobody really knows if there are these pings of death out there. It's worth noting that, and I think it's something you need to be aware of. So it's just new territory. Built-in features of V6 that promote security, they can also promote insecurity if they're used for evil, and we'll talk about that a little bit. Also, just multiple protocols means multiple policies. I don't know how many people in this room were around in, say, 1993 or 95, in that time, when TCP/IP was really taking off, not just on the internet, but also on corporate networks. At that time, I was working on networks that had a lot of netware. So we had IPX, and in one particular place, I was working on a network that had a nationwide IPX network. I could see printers in Alaska. It was basically all done using RIP. It was a big mess, actually. They also had IP on their network at that time, and the access control lists and just the policy about routing and everything else was an absolute disaster. You could easily have this problem with v6 and v4 if you aren't careful. You know, I think it's something that the policy side of this is probably the most important thing. If you want to have a secure network, you have to make sure that any decisions you make about what happens in v4 also happen in v6 in a similar way, at least wherever possible. So, you know, more protocols, more problems. IPv4 and IPv6 are not the same. IPv4 features don't necessarily equal IPv6 features. You know, for instance, IPv6 doesn't have ARP. This is a huge thing. People are used to securing, you know, their networks with kind of layer 2, layer 3 ARP stuff, to where, you know, MAC addresses are bound to ports and other things like that. You can't necessarily do that in v6 the same way because v6 uses ICMP v6. You have similar concepts there. ICMP v6 is very multicast based and it supports similar things. I mean, you still have MAC address on hosts and stuff like that. However, finding a switch that supports filtering of ICMP packets in that way right now is very difficult. D-Links makes some stuff that works, believe it or not. Cisco makes some stuff that works, but you know, you have to have the right iOS image and things like that. It's just not very easy to do. So it's something to be aware of. You know, one thing you can do right now, if you need that level of security, is to look at like 802.1x, something that's basically agnostic to the protocol and use, you know, it works at the Ethernet layer. That you can simulate a lot of that same access control and whatnot using that technology, which at least will help you right now. I expect that within a year or so, you're going to see just about every switch that Cisco makes, everything that Juniper makes. And you know, given that D-Link has switches out now, even Linksys and other people will start to make managed switches that support some of these v6 filtering functionality. It's also worth noting ICMP v6 is critical to v6 functionality. Fragmentation in v6 is drastically different than it is in v4. And ICMP plays a really big role in that. If you filter ICMP, you're going to break your v6. And this is basically how it works. In v4, fragmentation happens at routers, or it can happen really anywhere a v4 packet is passed. Usually that's in a router. In v6, that's not the case. What happens is somewhere, you send a packet out, somewhere along that transit path, a router will say, this packet is too big, I can't pass it on. It sends an ICMP packet back to the source host. The source host then fragments the packet itself and sends the fragments on. This is a huge difference. If you filter those ICMP packets, the packets just fall on the floor. Your host never knows that its packet was too big, it doesn't get forwarded, and your connection will literally just die right there. Another big difference is DHCP. John mentioned earlier DHCP was developed for IPv6, and router advertisement, all that auto configuration stuff was, you know, people thought about that for v6. It was all backported to v4 in one way, shape, or form. When v6 came out, it had no DHCP v6. It actually just had router advertisements. DHCP v6 was added on later in order to provide functionality that the router advertisement stuff just didn't do. So, for instance, with RA, you can't get name servers, at least not by default. And that's a big problem. You can't get network time servers and things like that. This has changed a little bit. There's been some updates to RA that allow some of this functionality, but a lot of people still want DHCP v6, and it functions a lot different. Basically, it uses ICMP to do all of this. You know, it is nothing like how it works in the v4 world, and that's worth noting. Hardware and software support is less than ideal. I mean, this is just a fact, and I don't know that this is going to change, you know, overnight. It's changing slowly. I mentioned earlier that we've worked with Brocade as one vendor that's starting to introduce really good v6 support for their load balancers. But you know, things like firewalls, finding good v6 support in firewalls outside of the open source world is difficult. I think that Checkpoint and some of the big vendors have v6 support, but I don't think that they have v6 support that'll look at all of the extended headers and some of the other things yet. That's going to take a while to happen. The good news is that there's basic support there now, I think, pretty much across the board. So you can do the basic routing policy. I think there is some worry about people taking advantage of some of the optional extended headers in v6 to fool firewalls and do some other things because they won't know exactly where to look in the header offsets to figure out that this is a bad packet or not. So probably the best thing to do is just have really strict rules that drops all that anomalous traffic on the floor and look through your logs and sort it out later. Yeah, I've mentioned switches and load balancers previously. Certainly they lack support there, but it's getting better all the time. One area that is actually really good is routers. I think if you have a Cisco or a Juniper, it supports v6, and there's almost complete feature parity between the two, which is really, really great. So security through obscurity. What does this mean? It means that we don't really know much about v6 security in some ways, and this is something people need to be aware of. IPv6 has been in many OSs for a long time, 10 years. Even Microsoft has had v6 since Windows 95 and 98. They released, I think, something in 1998, before it was even in final form, that would give you basic v6 support for Windows 98, believe it or not. The Kame and Wide projects for Linux and FreeBSD provided IPv6 support basically while the RFCs were being written. I mean, they've had it almost since the beginning of time. And OS X has had it since it came out because it was based on FreeBSD. But they aren't very well tested. You guys, how many people in this room have run IPv6 on their laptops? Some people have, but it looks like the majority of you haven't. And that's generally the state of things. A lot of the stuff just hasn't been tested. Applications haven't been well tested. You have, it's not just the fields. Well, you can even put an IPv6 address into this application. Is it capable of logging a v6 address? If you have, any sort of log configuration stuff, does it support v6 well? Apache is a great example of an application that works really, really well, but there's a lot of applications that just don't. Which leads to stack smashing, buffer overflows. Who knows what we'll find with v6? I think that there's a lot of unknowns out there for applications that they tacked on v6 support real quick, but they didn't think about the consequences of what they were doing. That's all going to be exposed, and it's just something I think that over the next few years we're going to have to deal with. Having good network monitoring, good log analysis, things like that are areas where you can try to catch this kind of stuff. There are just many unknowns to v6. The good news, though, is that exploits aren't well known either. I'm sure that there are probably even people at this conference that have taken v6 apart, read the RFCs, look at all these stacks, and they have some 0 days in their pocket right now waiting to wield against some site somewhere. But I think that those people are in the minority. The good thing about that is that security today is a lot better than it was back in 1995 and 96. Back then, people didn't even really think about security. There wasn't a lot of malicious activity on the internet the way that there is today. When v6 stacks were designed for a lot of these hosts, they were designed with the fact that people are going to try to smash this. They're going to try to get into it. We have good practices for auditing code and things like that now that we just didn't have before. So I think that things are a lot better built now. That will help us. It's also difficult to scan v6 networks, at least from outside the network. Nmap, tools like that, they don't work as well over v6. There's some multicast exploits that you can use to discover v6 networks. Some of those can be used remotely. A lot of them you have to be local, and using basically 802.1x and other local network tools to secure your Ethernet are good ways to mitigate those kind of attacks. It can be hard to guess addresses. It can also be easy to guess addresses, depending on the addressing format that's being used. We'll talk about addressing formats here in a minute because that can be confusing in itself. But generally, v6 addresses are just complicated. It's not nearly as easy to sequentially walk through a v6 network to try to discover hosts that way. And that can be helpful. In a lot of ways, everybody's starting over again. Everybody's going to have to explore this and figure out what's the right thing to do how to exploit it, but also how to protect it. The good news is that you can't exploit something until you know how to exploit it. So at least right now, I think the good guys have a little bit of a lead. So security features built into IPv6. These are actually really, really cool and very, very useful. You have the ability to set up encrypted sessions between hosts, cross-platform. It just works. Right now, it's mostly using pre-shared keys and things like that. However, opportunistic encryption, which you can do in v4, it's coming to v6. It's really just a matter of people writing the software and doing it. This allows you to have on-the-fly VPN servers, on-the-fly encryption between hosts and authentication of hosts between hosts. It all just works. It's really neat. You can use this to enhance your routing security. So you can have routers running BGP between each other using AH to make sure that there's no spoofing going on between those links, which can help shore up your BGP connections and other routing connections. It also can provide routing layer security. You can have your typical three-tier application, for instance, and use AH on the back end to make sure that all of the hosts are talking, they know who they're talking to. They're authenticating all those sessions. It's a lot like running SSL or something like that on your back end, but you're doing it down at the IP stack. And It should be lower overhead. I think eventually you'll start to see hardware that supports accelerating this stuff, just like you see some TCP